Okay, all good. Awesome. All right, good afternoon, everyone. So I presume you are here because you want some help with unit conversions or thinking about dimensional analysis, converting units from one value to another, right? Well, that's what we're going to be talking about here to give you guys some help with unit conversions. So my name is Michael Persant. This is Melanie Yasko. If you don't know who we are going to be conducting this workshop here. So the way this is going to go is we're going to talk about unit conversions. We're going to try and give you some different perspectives on trying to make unit conversions feel more intuitive, show that how you can at least think about them more intuitively so that you know that if an answer you get is in the ballpark of what should be correct. And then we'll get more into more like complicated conversions that might be a little bit less intuitive that we can solve with just by setting things up correctly using math. And we'll get into kind of a worksheet later where we'll do that. But to start off here, though, let's bring up the example that was in the description for this workshop here, where we have a student, and let's say they're taking an exam, and they're told, okay, a football field is 300 feet long. And so we have a football field that is 300 feet, and there are 5,280 feet in 1 mile. So with that information, convert the length of that football field into miles. And so the student does the problem on their exam, and the answer that they get and the answer that they write down is 17.6 miles. Now, can we all agree that a football field is not 17.6 miles long? I think we can pretty much safely say that. That's roughly the distance from here almost all the way up to N, right? So clearly this is not correct here. Now, given all that information, what do you think the student did wrong? What did they do wrong to get to that answer? Yeah. So do you think they converted to a different unit? Possibly. They might have done this on exam. Any other ideas of what they might have done wrong here? They did divide it wrong, yeah. What they did here was they did 5,280 divided by 300. And that gave them 17.6. Now, why do you think they might have made that mistake? What do you think could have contributed to them making that mistake? Is there any logic to why they might have done it that way? What do you think could have caused them to make that sort of mistake? Like the formula they used? Okay.
You don't like fractions? Who likes fractions?
Fractions are easy.
Do you think everybody likes fractions? No.
Do you think possibly that they might have just seen a bigger number and a smaller number and thought it made more sense to divide the bigger number by the smaller number? That's something that they might have done. There's all sorts of things that they might have done to lead to this mistake here. But when in actuality, what they really needed to do was they needed to take that 300 feet, they needed to divide that by 5,280. And that would have given them a very small number of 0.0568 miles. Clearly a much smaller number there, converting that into miles. Now, there's a lot of reasons why they might have made a mistake like that. Maybe they were taking a test and they were nervous and they did what they just thought looked like it made sense. There's all sorts of things that they could have done that could lead to an error like this. But what we want to think about here is, let's think about just using logic, kind of remove yourselves from the math, and let's just use logic to think about how a number should change if we go from one unit into a different unit. So let's think about some quantities that you probably use all the time in your everyday life. We use different quantities and numbers and measurements all the time. You measure the length of a room, or you buy a drink at the store and it's got a given volume on it. There's all sorts of measurements that you utilize every single day. So let's just take something real simple. So let's say you've got 48 hours. So 48 hours is how many days? How many days is 48 hours? Yeah, it's 2 days, right? So you just did that real quick in your head, right? You just did that conversion very quickly in your head. And how did you get from 48 hours, how did you get from 48 hours to 2 days? What did you do? Divided what by 2?
48. So there's 24 hours in a day.
You mean divide 48 by 24? Yeah, divide 48 by 24 to get 2, right? Exactly. All you did there was you took that 48 hours, you divided that by 24 to get 2 days, right? Exactly.
A little bit of backwards logic.
Yeah, it's all, yeah, you divided by 24 to get 2, exactly. So you just did that instantly in your head, right? That was something you didn't have to think very hard about that to get to that answer. But let's break the logic of that down to show exactly what you just did in a split second in your head to get from 48 hours to the same number of days. So, in what I just asked you to do here, we converted from hours into days there. So, in converting between those two different units, are we converting a smaller unit to a bigger unit, or are we converting a bigger unit to a smaller unit? Well, what's bigger, a day or an hour in amount of time? Yeah, a day. A day is bigger, right? So we're going from a smaller unit to a bigger unit, right? This is a smaller unit of time. So an hour is a smaller unit of time, and a day is a bigger unit of time. So we're going from a smaller unit over to a bigger unit, but then look at what the numbers did. We just said 48 hours converted into 2 days, right? 48 hours converted to 2 days. So our unit got bigger. The unit there got bigger, but then what happened to the number? Did the number get bigger or smaller? Exactly, the number got smaller, right? The unit got bigger, the number got smaller. So even without doing the math, which you may be able to do quickly in your head, or maybe you can't do it quickly in your head, something you should always think about here is look at that kind of inverse relationship between how the unit changes and how the number changes. If your unit's getting bigger, that means your number is going to be getting smaller. If your unit's getting smaller, that means that your number's going to get bigger, right? So for example, if you've got, say, 30 yards, well, 30 yards is how many feet?
5, 10.
No, a yard is 3 feet. A yard is 3 feet.
90.
90, yeah. 30 yards would be 90 feet, right? Because 1 yard is 3 feet. So if we've got 30 yards, that's the same thing as 90 feet, right? Again, notice here in this case, we know a yard's bigger than a foot, right? Because a yard is 3 feet. Notice that the unit got smaller and the number got bigger. So the point we're trying to make here is, even without doing the math, This kind of logic should always be where your mind should go when you're doing these unit conversions. I'm trying to convert from one unit to another one. Before I even try to do the math, should my number get bigger or should my number get smaller? That's the first place that your mind should go if it's a simpler unit conversion. That's a great intuitive piece of information to keep in your head when you're doing this. Now, if you guys have questions at any point, just stop me if you guys have any questions. Any questions so far about these intuitive examples? Awesome. So let's utilize that logic with a couple more examples. So let's say 1 year is how many? 1 year is how many minutes? Now, you probably can't do this math in your head, but without doing any math, let's look at that and go, okay, I've got 1 year and I want to convert that into minutes. So am I going from a bigger unit to a smaller unit, or am I going from a smaller unit to a bigger unit? Exactly. A year is obviously bigger than a minute. So when I convert this 1 year into minutes, when I convert that 1 year into minutes, should my number get bigger or should my number get smaller? Yeah, it should get bigger, right? I'm going from a bigger to a smaller unit. So the number should go from a smaller number to a bigger number. If we have 1 year, well, there's 365 days in 1 year. And there are 24 hours in a day. And then there are, and then there are 60 minutes in 1 hour. And if you multiply all that through, 1 times 365 times 24 times 60, you get 525,600 minutes, just like the song in Rent. So, but again, notice, smaller number up to a bigger number as the unit got smaller. So the whole point here is, again, think about your unit conversions intuitively so that you can look at your answer and say, okay, does my answer make sense? If I'm expecting a bigger number, do I get a bigger number? If I'm expecting a smaller number, do I get a smaller number? Don't abandon that logic and get lost in the math. Think about whether or not your answer makes sense when you're doing these conversions. All right. So, you guys have any questions about any of that so far? Okay. Now, when you guys are doing unit conversions, they're not always going to be this simple. They're not always going to be simple one-step conversions or conversions that you can do in your head in a split second. Oftentimes, the conversions we do are going to be a little bit more complicated. But we can set up our math and set up our conversions to make it to where we end up with the correct answer every time. So we can move on to take a look at some more complicated stuff. We've got some worksheets that we can check here.
So if the year was like 3/4 of the year.
Mm-hmm.
Okay, so.
We got 3/4 of a year?
Yeah, 3/4 of the year.
So like 0.75 years?
0.75
Yeah.
year, yeah, 0.75.
Mm-hmm.
Okay, so then, okay, so that's, how do I know, okay, so that's basically 9 months, is that 9 months, right?
Well, you don't have to do all that in your head. We
Okay.
can just change this 1 here to 0.75.
Okay,
So just do 0.75 times 365 times 24 times 60.
okay.
So the people in WebEx, if you want to scan this code, hopefully we'll take you to this webpage. We're looking at a conversion handout.
And you still get a number way bigger than
Here in
0.75, right?
class.
Yeah, whatever that number is, can be
Okay.
way bigger than 0.75, right?
Yes,
So if you can see this QR code, you can scan it. It should bring you to a web page that has a handout we're gonna look at. So I'll give you just a second to do that. It's not complicated. You can keep up with me even if you don't have the handout. So what he didn't tell you, what Professor Croissant did not tell you is, he's a chemistry professor. Did y'all know that? So if you need to take chemistry, he is amazing. I teach math. I have a degree in chemistry though, so it's all related. Okay, so I'm gonna go ahead and get started. I teach math, and a lot of times people get overwhelmed with just the thought of doing something. Sometimes the process itself isn't challenging, but we get in our own way. So I've made up some random conversions. Maybe we're bartering, we have some animals and we're gonna try to get different animals. And so we have this conversion box, 1 cat will buy you 6 frogs, 1 frog gives you 36 crickets, and so on. So this is just going to break down the process, an easy way to set up these conversions and these calculations without getting like emotional about it. I think a lot of times I have a degree in chemistry, so I've taught this to a lot of students. And sometimes it's overwhelming to think about all the units, like the ones on the back. Last page. Convert miles per hour to inches per second, kilometers into inches, all these different things. Sometimes we start thinking, oh gosh, what's the conversion factor? We kind of panic. So this is just gonna introduce us very slowly. Please don't feel like I'm insulting your intelligence. I do not know you. Making sure we're all on the same page. So how many pigs can you buy with 30 dogs? So we're going to do something called dimensional analysis. And we usually start with what we're given. We have 30 dogs. So we're gonna do 30 dogs. And I'm gonna use this method, some people call this the fence post method. We're just multiplying.
I call it the railroad method.
Railroad method. All across the numerator and across the denominator. Instead of putting multiplication there, I just put these little fence posts. So 30 dogs, we're trying to get to pigs. So we look somewhere in our chart, do we see anything in here that has a relationship between dogs and pigs? Yes? What do we see?
4 pigs and 5 dogs.
4 pigs and 5 dogs. Okay, I'm gonna highlight it just for now. So hit pause for a second. I teach math. If you have a number, let's say, what's your favorite number? 2. Remember you have the number 2. What do you have to multiply 2 by to still get 2? 2 times what gives you 2? 1. So in math, if you have an expression of any sort, you're allowed to multiply by the number 1 to make sure that you get the same expression. 1 is called the multiplicative identity. You multiply anything by 1, you get that value back, right? So we're gonna multiply by a whole bunch of 1s. Very fancy number 1s, okay? So how many eggs are in a dozen? 12. You have a dozen eggs, you have 12 eggs. Same thing? 2 different ways of saying the same thing. So we're gonna multiply by a fancy number 1 right here. Okay? It's 2 things that are equivalent. Mathematically, they're equal to each other. We can say they're 1. So I can say, for example, that 4 pigs over 5 dogs is equal to the number 1. That make sense? They have a relationship, they're equal. Or I could say 5 dogs divided by 4 pigs. They're equal to each other, have equal value. That would also be equal to a number 1. Does that make sense? So you say 12 dozen eggs versus, 12 eggs versus a dozen eggs. They mean the same thing. So I'm going to multiply by a number 1 here. And I know y'all told me the ratio I want to use, the factor I want to use, is 4 pigs equals 5 dogs. So I can write it as 4 pigs over 5 dogs or 5 dogs over 4 pigs. Now this is where the logic part comes in. We always want our units, in this case, we want to end up with pigs. We need dogs to cancel. So which of these do I want to use so that dogs will cancel? Top one? I say I want the dogs on the bottom, right? If dogs are on the bottom here.
And we call these conversion factors.
Yep. So these conversion factors. 4 pigs divided by 5 dogs, mathematically they're equal to each other, so it's the same as multiplying by the number 1. Does that make sense? Look at your units. Dogs cancel because there's a dogs in the numerator and dogs term in the units in the denominator, right? Okay, and then Professor Croissant sort of already talked about this. We're going to multiply everything on top. So all of your stuff in the numerator, multiply, however many you have, and divide. So we would do 30 times 4 divided by 5. You could reduce this if you wanted to, and do 30 divided by 5 is 6 times 4. But these are gonna get more complicated. So we would say we would get 24 pigs. Y'all see how I did this?
30 times 4 divided by 5.
Yep. So type it in your calculator, 30 times 4 divided by 5. That's 24 pigs. Does that make sense? Okay. So I'll leave the next one to you. I gave you the answer. You can try to get it.
Is that like ratios?
Yeah.
Like, so you automatically put the 30 over 1 and then just cross cancel, or,
Sure.
excuse me, butterfly method? And you do, like, how do you?
Be real careful. When students tell me butterfly method, technically the butterfly method has an equal sign in the middle.
Oh, okay. Well,
But-
yeah,
but- When they say that, but you can cancel. If something, it's like this.
Cross cancel.
If I have dogs over dogs, they cancel out.
Right.
Yeah, so if it's in the numerator anywhere and in the denominator anywhere, yes, they can cancel.
And what you just said is really important about, you say that 30 over 1, right? That is actually the mistake the person converting the football field length, that's actually the biggest mistake that person made. They put the number they were converting in the denominator. But that number that you're converting should always be in the numerator over 1.
Over what?
That was the real big mistake that that person at the very beginning made, was they put their 300 in the denominator. You gotta have the number you're converting in the numerator.
Now, I always start with what they've given you. So number 2, I'm leaving it for you. Now, if you want to do, this is kind of weak for you, you can try this. We'll skip to number 3, and I have the chart down here again. How many sheep can you buy with 12 cows? So what are we gonna start with? Always start with what you're given. What are we starting with?
The 32.
No, in the problem. Start here.
Over.
What am I given? Which part of, I'm given a number and a unit.
12 cows.
We're gonna start with 12 cows. So we're gonna do 12 cows. You can put it over 1 if you want to. Okay, now we're looking for a conversion factor here with cows. So which ones have cows in them? Which conversions have cows?
So cows and pigs.
Where do you see that cows? Over here. Okay, anything else have cows in it?
Horse and
Horse and cow. Okay. So which one am I going to use? Well, no matter what, where do I want the cows?
With the cows, and then denominator.
I want the cows in the denominator, whichever one I choose. I want to put the cow part in the denominator and the other part of the conversion factor in the numerator. Okay, so let's just try the, I'm gonna try the one that doesn't work. Let's try 2 cows and 1 horse, just so you can see. So cows would cancel, now my new unit is horses. Trying to get to sheep, what happens? Do I have any way to get from horses to sheep? No, so can't use that one, that wasn't the right one. So let's try the one that y'all mentioned. So 1 cow is equivalent to what?
4 pigs.
4 pigs. Okay, so what are my new units right now at this moment? What are the units of the number? Cows canceled, right? What's my new unit?
You got pigs right now, right?
We have pigs. Now how do I go from pigs to sheep?
3 pigs to 4 sheep.
3 pigs to 4 sheep, okay? 3 pigs to 4 sheep, okay. So, what goes on the bottom? The pigs. So 3 pigs to 4 sheep, okay? Units cancel again. Pigs in the numerator, pigs in the denominator. Remember, this is mathematically the same as if I had multiplied. All of these use parentheses. Okay, so my new units are what? Sheep. Am I done? I need to multiply it out, but have I gotten the unit I want?
Yeah, sheep.
So then we're just gonna multiply all the numbers in the numerator by all the numbers in the, divide by all the numbers in the denominator. So 12 times 4 times 4, and then you calculate divide by 3. So multiply all the way across, and then divide on the bottom. Got it? And some of these you can do in your head, but we're gonna give you some later where you can. What do you get?
64.
64, give me the unit. 64 sheep. So for those of you just joining the meeting, I'm gonna take just a second, and there's a QR code if you wanna scan it. Zoom out just a bit. There's a worksheet on this, on our STEM Expo, so STEM Workshop website. You can get this handout. I'm actually going slow enough, hopefully you can write it down if you need to. I'll give you just a second. Okay, let's try another one. So you can see I've given you the answer to number 4 and number 5. So you can try those on your own. Let's look at number 6. How many horses can you buy with 160 dogs? What do we start with?
Horses.
And we always want to end up
Sorry. Or the 160 dollars.
Yep.
given dogs. So 160 dogs. Okay, remember that could be over 1. I'm trying to get to horses. So go back to your chart. I have dogs, I'm trying to get to horses. Do you have anything that says dogs, horses? No? But I have 2 that have dogs in them, right? 4 pigs equals 5 dogs, and 2 dogs equals 3 cats? Okay, you want to kind of think ahead a little bit here. I'm ultimately trying to get to horses, right? How many horses? So, does cats get me closer to horses, or does pigs? Let's start with the cats. So here's cats right here. That's the only thing else that has cats in it, right? Cats gets me to frogs. And the only unit with frogs is crickets. See that? So can I use that one? See what I'm saying? If I wanted, I've given
Okay, we're looking for, okay.
I've given 160 dogs.
Mhm.
So the conversion factor that has dogs in them, I've highlighted both of them. So let's start with this one. 2 dogs equals 3 cats.
Okay.
So I've circled the thing that the only other conversion factor that has a cat in it. 1 cat equals 6 frogs, right?
Okay.
But the only other conversion factor now that has a frog in it gets me to crickets. So that seems to be a dead end, right? Okay, so I'm not going to use that one. So let's try this one. I started dogs, that can get me to pigs, right? Remember, I'm trying to get to horses. So I'm at pigs now. What else in the problem talks about pigs? What conversion factor? 1 cow is 4 pigs. Can I get from a cow closer to a horse? 1 horse, 2 cows. Y'all see, you kind of, and this is made up, and it's on purpose, so you don't get overwhelmed with all the units. But you're trying to find ones that get you in the right direction. Does that make sense, the process? Okay, so which one are we going to use? I've circled 3 of them now. So I've given 160 dogs. What should I write next? Where do I need dogs to be next?
Denominator.
In the denominator. So I need a conversion that says dogs, and I need to put the dog part in the denominator. So which one?
2 dogs, and cats?
Nope. The cats didn't work, remember?
Okay. Oh, the 4 pigs, wait. So.
I should have put them closer.
Okay. So we.
So the 160
One
dogs.
count, one count the 4 pigs?
Yeah, but we have to start with dogs.
Okay.
So we've kind of gone down the chain, right?
Yeah.
We said this one didn't work. Dogs and cats did not give us to the right location,
Okay.
right? So we said 5 dogs equals 4 pigs. If we had pigs, y'all told me pigs could give me to cows,
Pigs. Okay.
and cows could give me to horses, right?
Yes.
So help me put it together. I have 160 dogs.
4 pigs.
4 pigs goes where?
Your numerator.
4 pigs
4
and
pigs, 5 dogs.
5 dogs. Everybody with me so far?
Cancel. Dog.
Cancel the unit of dog, dogs over dogs cancels. What's the new unit right now?
Okay, so now we are 1 cow and 4
Right, but what
pigs.
unit am I at right here, this step?
Pigs.
Pigs, okay. So now I need to change from pigs to, you said,
1
cows?
Uh-huh,
So pigs has to be on the bottom.
yes. 4 pigs
So,
and 1
so
cow.
1 cow and 4 pigs? Y'all check, is that right? 1 cow and 4 pigs?
Yes.
Okay, And then pigs cancel, what's the new unit at this step right here?
Cow.
Cow. Okay, now we're gonna try to go from cow to what?
1 horse.
Cow to horses, right?
Yes.
So 2 cows is equal to,
2 cows, 1 horse is your numerator,
1 horse in the numerator.
and 2 cows is the denominator.
Everybody with me so far? Cows in the numerator cancels with cows in the denominator. What is the new unit at this point right here?
Horse.
Horse. Okay, and then multiply it out. All of these, multiply, 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 and then divide, divide, divide. What do you get? 16? Because in your calculator, you do 160 times 4. I guess that's the only thing that's multiplied. And then you're gonna do divide by 5, divide by 4, divide by 2, and enter.
Oh, so you wouldn't multiply all that together?
I would do this
Get
times
one.
this, and then divide. I do it all in one step.
If you want to, you can do 160 times 4, and then you can do 5 times 4 times 2, and then do whatever 160 times 4, divide that by the result of 5 times 4
That's
times
what I
2.
did, okay.
Yeah.
But the problem with that is you're really careful with division. Sometimes if you're dividing by something that's divided by, your calculator thinks it's multiplication.
Yeah, if you're gonna do that all at once in your calculator and put it in like that, you gotta put parentheses around everything in the denominator.
Yeah, probably the easiest thing, because I have a degree in chemistry, and I messed it up if I didn't do all the numbers on top. So 160 times 4, divide by 5, divide by 4, divide by 2. You just do
That's-
them all separately.
That's the way I do it too, and that's usually the easiest.
So much faster, and you're not gonna make a mistake.
Don't try to put it all in your calculator once, just do it sequentially like that, it'll make it easier. And see, the nice thing about this railroad or fence post method that we're using here is we can write this exact same kind of method with the intuitive conversions we were doing before. I asked you how many days 48 hours was. Setting that up in the railroad method just looks like this, right? We start off with 48 hours. The equivalents, so the 1 day and 24 hours are equivalent. So you set this up in your head where we said 48 hours over 1. 1 day is 24 hours. We got our hours to cancel there. 48 divided by 24 gave us 2 days.
And I just know those on the back. Not that one.
So where it says 1 horse equals 2 cows, it could be 2 cows equals 1 horse.
Absolutely.
It could
Yes,
just be
yes.
reversed, okay.
Okay? So you wanna do a couple more of these before we go into the math and science ones? Y'all feeling okay? Okay, so that is,
What's next, the miles per hour?
yeah, you want, everybody ready to flip to that, or you want to do some more with cows and horses and pigs?
So 16 was the answer?
16 horses?
So would it be wise just to multiply all those on the bottom and then divide by what you get on the top?
Other way around.
Divide top by
You
bottom.
could,
Yeah, but,
Yeah.
but I mean like multiply the 160 times 4 and then it gives you the 640. Then you multiply all of those and then you divide that answer by the 640, but which gives you the 16.
Then it's 5 times 4 times 2, that's
you
gonna,
can.
that's gonna give you 40, and then you can do
Yeah.
640 divided
Yeah,
by
you
40,
can.
you can.
Okay.
That'll get you to the same place. When you're putting that in your calculator, you're gonna be more prone to putting it in your calculator wrong if you try to do it that way, but it'll get you to the same place as long as you put it in your calculator, right?
Does anybody else want to see any more cows, pigs, and horses, or jump to the math and science? Get back.
Do you do medical conversions?
I got one on here.
We've got one on there that just has to do with that, yeah.
So ready to jump, you'll get the idea, ready to do one with math and science? Yes? Okay. Okay, so there's someone, there's the page 2, you practice on your own. So following up with what Professor Croissant did, these are more along those lines. So these are some common conversions. You really should commit these to memory. If you're going to take a chemistry class or a physics class, you need to know these. 5280 feet in a mile, most of the students do not know that. We use that in math, we use that in chemistry and physics, so really should know all of these. 2.54 centimeters is equal to 1 inch.
Yeah, I would agree that pretty much every single one of those are on there. That's really stuff you should just know.
You should know backwards and forwards without
Yeah,
having to
you should.
Google. Okay.
You should know what all of those are.
Okay, so number 12, convert 68 mph. What is mph?
Miles per hour.
Miles per hour to inches per second. What do I start with?
68.
68.
Miles per hour.
Okay, but now where do I put my units?
So what does that per mean?
Ask me again, Ms.
So you told me it's miles
It's miles per hour, right?
per hour.
Mhm.
So where do I put my units?
We have 68 there in the numerator because we always start the numerator, but where do the miles and hours go?
Under
Which one?
the denominator,
What goes in the denominator?
What goes in the denominator?
the seconds?
Well, no, we're getting there.
Okay.
But if I'm just looking at 68 miles per hour, so I've really got two things. I've got miles and I've got hours.
Uh-huh.
Where do I put them?
Your denominator.
Which one? Both of them or
So
one?
miles per hours.
Okay, miles on top and 1 hour. You cover 68 miles
Okay.
in 1 hour.
That
Miles
word
per hour.
per, that word per there implies division.
Okay.
Miles divided by hours.
Another way of saying it is 68, next to miles divided by hours.
Okay, so now we're going to have to do two conversions though. We have to change miles to inches, y'all see that? And we have to change hours to what?
Seconds.
Seconds. We're gonna do both of them. I like to start with the bottom one. I don't know why my teachers always started off with hours.
You can do them in any order.
Any order. Let's go ahead and take care of the bottom one first. So how do I go from hours to seconds?
60 minutes and 1 hour.
60 minutes is 1 hour, so what goes on top and what goes on bottom?
60 minutes and then, no, the 1 hour on the top.
Uh-huh.
And then 60 minutes on the bottom.
How do you know? You changed your mind. How did you decide?
Well, because we need to cancel out.
You need to cancel it.
There you go.
Watching where you put it, the big thing is I need this part to cancel. Okay, so now look at the new units. Before we do anything else, what are the units we have right now?
Miles and minutes.
Miles per minute,
Miles per minute.
right? Because it's miles over a minute, so miles per minute. Okay, let's keep going. How do you get from minutes to seconds? That's what I'm still trying to get from the denominator.
60 seconds and 1 minute.
60 seconds in 1 minute. Tell me how to write it. What goes on top?
1 minute.
1
60
minute.
seconds.
And then on the denominator is 60 seconds. So far, so good?
Cancel out.
So minutes cancels. What are the new units right now at this step?
Miles and then.
Miles per second. So I'm good with the per second part, right? I need to do what next? Change miles to what?
Change miles to seconds? No, change miles to
Miles to
inches.
Yep.
Miles per inches.
Because we have a dimension, like a length, and then a time period. We covered the time period, we changed that. Now we're going to adjust the
Miles to inches.
miles to inches. Yep. Okay, so I don't have any conversion in here that goes miles to inches, and you can probably Google it and it'll tell you what. But I don't need it because I know all of these fun conversion factors. So what in here says miles? Any of those have miles?
the
Got what?
5,280 feet, 1 mile.
Okay. What goes where?
Miles on the bottom, 1 mile
Okay.
on the bottom. The feet, 5,280 feet on top.
Perfect. Cancel your units. What cancels?
Mile.
Miles, even though it's way over here, if I look, even though it's way over here, and this one's over here, it doesn't matter. One is in, they're all multiplied, across the top and across the bottom. 1 miles is in the numerator, the other miles is in the denominator, they cancel mathematically. Does that make sense?
Yes.
Okay, what are the new units right now at this step?
Seconds and feet.
So say them correctly.
Feet per second.
Feet per second,
Oh.
right? You are correct that we had feet in one place and seconds in the other, but start with the numerator, feet, and then per tells you what's in the denominator. Okay, so feet per second, how do I go from feet to inches?
You put, 1 foot on the denominator.
1 foot in the denominator, okay? And then what in the numerator?
12 inches.
12 inches. What about my units? What cancels?
The feet,
The feet. What are the new units right here?
12 inches per second.
Inches per second. Okay, then I'm gonna type this in a calculator. I'm gonna do 68 times 5280 times 12 divided by 60 divided by 60 equals. Just take all the numbers, multiply across the top, and every one that's in the bottom, hit the divide first, then hit that number. Divide first, then that number. And what do you get? Leave it as a decimal. Go round it up 2 decimal places.
Yeah, like 2 decimal places.
2 decimal places. There's lots of rules in your chemistry and your physics class about something called significant figures. We won't get into that here. We'll just round this one to 2 decimal places.
I don't know how to change my calculator to decimal fractions.
It gave it to you as a fraction?
Yeah.
Yes.
I just got this.
Oh, you have it.
So it's 1,196 and
0.80 inches. Perfect. Got it? Okay. Okay? Are you getting that?
So we would write it as inches.
Inches. Oh, I'm sorry, inches per second. I forgot the per second.
Yeah.
Inches per second. Thank you, Cynthia, for catching that. Inches per second. Are you getting that? You see how we're doing that or not?
It's just a shortcut, yeah. It's like a shortcut.
But the biggest thing
Yeah.
is you can multiply all the way across and multiply the bottom and then divide, but this is, you know, you can,
Yeah.
I mean, way less fun to make a
Yeah.
mistake. if you do it
especially
like
when you
this.
get a really long one.
Yeah, like this is a very long one. And notice what we're doing here is exactly the same thing we just did over here with converting like the years into the minutes, right? I wrote it quickly here, but you could write that in the exact same railroad method that we're doing up there on the board, or up there on the slides.
Does this make sense? Yes, yep. Okay. So let's jump ahead to, I guess this one. This one is going from, convert 68.5 kilometers into inches. So we're changing systems, right? We have the metric system and our customary, our standard system. So this is a fun one. So what do we start with?
And
68.5 kilometers. Okay? And we're trying to get to inches. So we need a conversion that goes from the metric system to our customary system or vice versa. So look in your box. Are there any conversion factors that change systems? You know what I mean by that? Systems, our metric system is in terms of meters and centimeters and kilometers and hectometers and
1
decimeters.
kilometer equals 1,000 meters.
Okay,
So it'd be
1 kilometer.
1,000.
Okay, 1,000 meters on
1,000.
top. Okay. And what's on the bottom? Is it not there?
Kilometer.
1 kilometer. Is that okay with everybody?
Kilometer.
Can you see right there? Oh, it's a little low.
Yeah.
Okay. Is that better or not?
A little more?
I can't move it up any more than I can't see the
Oh, you
conversion
can
factor.
see it, you can see it.
Is that okay? So units, where are we at right now?
Meters.
We're meters, right? So how do you go from meters to inches?
100 centimeter to 1 meter.
Okay.
100 centimeter on top. 1 meter on the bottom. Cancel
Okay.
out your meter.
Now we're at
Centimeters.
centimeters. Okay, now how do we go from centimeters to hopefully close to inches?
Inches. Centimeters to inches. Right here, 2.54? No. Wait.
Yep.
Is that centimeters? Yeah.
2.54
2.54, okay.
1 inch on top. Okay, and the units cancel, centimeters in the numerator, centimeters also in the denominator.
2.54
Centimeters cancel out.
Okay, so what's the new unit right now?
inches,
Inches. Is that what we need?
yes.
Okay, then in our calculator, you're gonna type in 68.5 times 1,000 times 100 divided by 2.54 equals. Multiply all the way across and divide everything on the bottom.
And do you expect the number to get bigger or smaller when you do it at the end?
Choose a big number.
Big number? Does that seem reasonable that you would get a big number based on what Professor Croissant said?
Yes.
Yeah, okay.
Because did we go from a bigger, because did we go from a bigger unit to a smaller unit?
Yes.
Exactly, so you're expecting to get a real big number.
Yes.
96,
2696,
394.
I didn't catch it.
269.
850
850,
point
394.
394. And there'd be some, your teacher would give you some indication of how they wanted you to round.
Yeah, I don't want to go around that, but yeah.
So,
2 million.
so does it seem reasonable that there might be over 2 million inches in 68.5 kilometers? Yeah? Should be, right? Because inches is a whole lot smaller than a kilometer.
We went from a bigger unit to a smaller unit, so our number went from a smaller number to a bigger number.
So look at number 14. Convert 4830 inches to kilometers. What do you expect to see here?
Smaller.
Smaller number.
A smaller number, right?
Okay, so tell me how to start.
For the 0 over 1.
Inches, don't forget units. Inches,
Numbers are meaningless without units.
That's right. okay? And then what?
So it'll be, 2.5, no, 2.54 centimeters.
Mhm.
And 1 inch.
That one is crucial, that conversion
Yeah.
factor, because it helps you go from one system to the other.
Go from the metric system to the American. That's usually the easiest conversion that allows us for lengths to go from the metric system to the American system or vice versa. Is the centimeter to inch conversion is usually the best one that we use there.
We're not the only country who uses this.
I think it's officially called the imperial system. There's like 2 other countries that use as well. Like Liberia and yeah.
So that's because the settlers came from here. Back over there. Okay, so from centimeters, now what?
1 meter over 100 centimeters.
So what goes on top, what goes on bottom?
1 meter over
1 meter on top and 100 is like this, so just,
Yes.
okay? Everybody with me? What are the units right now? Meters. We're getting a little bottom heavy, right? If we finally put 100 on the bottom, we're not going to yet, but we got 100 on the bottom. So we're fixing to do some more stuff on the bottom. Or we're not just kidding.
1 kilometer on top and then 100 meters, or 1,000 meters on the bottom.
1,000 meters and one like that, check.
And then the meters cancel.
Meters cancel, does that seem reasonable? Okay, so what do you get?
Kilometers.
Units are now kilometers, perfect, that's what we wanted, right?
Yes.
Type this in, 4830 times 2.54 divided by 100 divided by 1,000 equals. And tell me what you get.
0.1, 226.
0.1262.
2682.
And your teacher again would tell you how to round. We're just writing it all down for now. It'll be, again, probably a little lesson on significant figures Thursday class.
Again, you expected your number to get smaller, so we went from a smaller unit to a bigger unit. We expected the number to get smaller, and the number did get smaller. How much smaller? Well, I don't know, we got to do the math. But we expect, it makes intuitive sense that the number changed that way, and we did the math with our rigorous method there to see what we get.
Okay, so there's another one like this, and then there's one about kind of a nursing example I got from one of our nursing instructors. You want to do 2 more?
Sure.
Okay, so how do I do number 15? What do I start with? 5,600 units?
Over
What goes where?
seconds over hours.
Check it. Start with what you're given. This is what I'm given.
Feet per second.
So feet goes where?
On top.
Okay, in the numerator, and then where does seconds go? The bottom in the denominator.
600 feet per 1 second.
Yep. In 1 second, you travel 5,600 feet. Well, 5,600 feet is covered in 1 second. Both of them mean the same thing. Okay, now what? We have to change 2 things. Like I said, I always like to change the time first. So let's go from seconds to hours. How do I do that?
2 hours.
60 seconds over.
60 seconds
Over 1 minute.
over 1 minute. Okay, so we have to do it in pieces, huh? Can't quite get there all at once. So seconds cancel.
20 seconds over.
I didn't hear you. Say it again.
Like 120 seconds.
So then,
No, that's
it's 3,600. Yeah. So now I'm at feet per minute, right? Now I need to go from minutes to hours.
1 minute. 60 minutes, numerator,
Okay.
and then your hour,
1 hour.
denominator.
What are the units right now?
Hour.
Feet per hour.
Feet per hour.
Okay, so hour's good, right? Got that. Now let's work with the unit in the numerator. We need to change feet to that kilometers, going back to the metric system.
would be 2.54.
That's what we're gonna use. That's the factor that changes from systems, but it's not in feet though. I have to get from feet to what?
To hour.
No?
So,
Feet.
So this is,
Kilometers.
this is the important one, right? This is the really crucial conversion factor that changes from one system to the other. 2.54 centimeters is the same as 1 inch. So yes, I have to change from feet, just like she said, to inches first. So tell me what goes where?
Oh,
12 inches on top.
12 inches on top, okay.
okay.
And
so
then
we
what?
gotta use that, we gotta get that feet, the inches first before we
Yeah,
use
feet
that
foot,
conversion.
it just doesn't.
Okay, so the feet cancel, feet in the numerator, feet in the denominator. What are the units right now?
Inches per hour.
Inches per hour. Okay, now we're gonna use that special conversion factor that you were talking about.
2.54 centimeters over 1 inch.
And I'm writing it like y'all are telling me, but my little brain writes it backwards. My little brain always writes the bottom one first, or whichever one I'm trying to cancel, and I put the other one in the other location. I appreciate y'all reading it to me, top to bottom, but when I think about it, I say I need inches, so we put the inches here, we put its equivalency in the other location. Does that make sense? So inches cancel, what are the units right now?
Centimeters per hour.
Centimeters per hour.
Centimeters per hour. Am I done? No. I need to go from centimeters to
Meters.
meters.
So it's 100 centimeters under
Okay. And the numerator?
1 meter.
1 meter. Yep. Okay. Units right now?
Meters per hour.
Meter per hour. You see what we did, Cynthia?
Yes.
Okay.
Yeah. I
And then now we need to go from meters to what?
1,000 meters under
1,000 meters in the bottom. Okay. And then the numerator?
1 kilometer.
Kilometer. What are the units right now?
Kilometers per hour.
Is that what I want?
Yes.
All right.
Kilometers per hour.
How are we doing off site? Everybody okay? Okay, then we're gonna multiply all the way across and divide, except for the bottom.
And even though this is even though this railroad or fence post that we built here is really long, sure, I could combine some of them and say, well, okay, there's 3,600 seconds in an hour, but using these multiple conversions is just things we're more familiar with. It makes it easier. We have to do less math in our head.
Less memorizing.
Yes.
Yeah.
So,
Let me know what you get.
6,144.78 kilometers.
Something like that, okay. That's writing on the screen, I can move it up a little bit.
yeah, move it up just a little bit, yeah.
How do I feel about this? Not bad, right? You're gonna kick butt on this in a chemistry class? When you get to take chemistry, who gets to take chemistry? Raise your hand. Who gets to take chemistry? Get to? When you get to take chemistry, then you'll be doing things about moles, and you'll get to do like Avogadro's number and use the atomic
Volumes,
weight.
acids.
All of that stuff will go in here, and it's gonna be so much fun.
It's not my year.
Get to take it, it's gonna be awesome.
And see, being able to utilize both just intuitive logic like we talked about at the beginning and also setting it up with the math is what can allow you to make less mistakes and work through this. Because, I can look at 5,600 feet per second. Well, going from that to kilometers per hour, well, I don't know how much bigger or smaller my number's gonna get, but we can figure it out just by setting up this mathematical way of writing it.
Yep.
So,
Okay,
some
here's-
conversions are easier, some conversions are smaller, but we can always work it out this way.
Here's a nursing example. I got this from one of our nursing professors. So they get questions like this all the time when they're doing the drug calculations. The doctor orders a medication, 40 milligrams, they say PO or Poquid, PO, quid, okay. Oh, QID, they still say, okay, QID, okay. You know more than I do. For a child weighing 32 kilograms. Are you a nurse?
Yes, ma'am.
Yes, okay, well then you know all about this. How do you do that
Yeah,
conversion?
but that's why I was like, it's been a hot minute since.
Okay.
Because everything is already fixed for us, unless like you're trying to figure out, like if you're hanging an IV and you're doing your drip rates, I can do all that in my head. But when it comes to actually writing it, because I'm an LVN, I'm fixing to go get my RN, so I don't remember. That's like,
I run it. I'm not sure.
Okay, so it's POQID. See, I learned something. So we have an order from a doctor, and we want to make sure that this child is going to have a safe dosage, right? Don't kill the child.
Exactly.
So there's several ways
See why
to
this is
do
important?
this. It's really important. Yeah, there's several ways to do this. We're going to do it the way that, like, it sort of follows along what we've been doing. So let's start with what we're given, what the doctor's going to prescribe. So, 40
Whatever medication.
milligrams. Okay, and then our nurse, what does POQID mean?
it's by mouth 4 times a day.
By mouth 4 times a day. Okay? So they get 40 milligrams. And now let's check the units here. We want eventually units to be milligrams per kilogram per day, which means day is also in the denominator like that. Does that make sense? When you slash, they're both in the denominator.
In chemistry, you'll see things written more like that.
Yeah. So this isn't really a conversion problem so much. It uses the same idea of tracking your units. We're not really converting, but we're going to try to start with the 40 milligrams, which is the 1 dose, right? And we're going to try to get it into this form. So 40 milligrams, well, how many times does this child get to take this medicine? A day.
4 times a day.
Because the day's in the denominator, right? So in 1 day, they take 4 times or 4 doses, let's just say 4 times. 4 times a day or 4 doses a day. Does that make sense? So the times is kind of like it's kind of a dummy unit because they're still getting a milligram every time. Or 40 milligrams every time, right? Milligrams wins out. They're just doing it multiple times. Does that make sense? So we're still gonna have this milligrams per day. You see what you get it right now? Okay, and then milligrams per day, now we need the kilograms where? In the denominator, right? So this is less of a conversion and more of just following and making sure you put things in the right place.
It uses the same logic.
Yeah.
Okay.
So where do I put the child's weight? In the denominator.
Did you want it?
Because, yeah, we're trying to match these units. Milligrams in the numerator, kilograms in the bottom, days in the bottom. Doesn't really matter that I switch the order. Mathematically, 3 times 2 is the same as 2 times 3, right? So then you would do this the same way. You'd say, well, I multiply across and then divide by the value in the bottom. What do you get?
160 milligrams.
Yeah, this is 160 milligrams per day, which gives you this part. But then you have to factor in the child's weight divided by the 3.2. So what do you get? 50, what are the units?
50
Milligrams is here. Nothing canceled, right? No units canceled.
Yep, nothing canceled out.
Milligrams per kilogram.
Per kilogram, and then day is also in the denominator.
Because we didn't cancel anything, right?
Right, so just make this. Does that make sense? So this is not conversions per se, but we are following the same kind of logic, building the system in the same way. Where do my units need to be? I'm putting that piece on the bottom. I was going to be an engineer when I was in college. I was taking calculus, chemistry, engineering, and physics my first semester. It was crazy. And there were a lot of times I didn't really study enough, and I didn't really know what my physics formula was or what my chemistry formula was, but I knew what the units needed to be, so I knew where to put it. And so if I knew what the unit was, I knew where to put it. Most of the time I said, oh, I got it. And I could reason through it. Okay, so 50 milligrams per kilogram per day is what this child is getting of whatever this medication is. So is it safe or not?
Yes,
Because it says 50.
anywhere from 50 to 100 milligrams. Well,
Does that make sense?
yes.
Okay. Yes, Ann?
I don't, would that be,
that's just what it is for one dose would be,
Saying each dose is 50.
yeah, then it would be safe because it says.
No, this is the whole day though.
Dosage,
Oh,
Because it's 40
dosage.
milligrams and we do it 4 times a day.
But it's the allowed amount per kilogram per day.
Yeah.
So he weighs
As long as it doesn't go over 100.
kilograms, so it's.
Yeah, so it's in the range of 50 to 100.
We've determined that by giving him that dose, he's having 450 milligrams per kilogram per day, which is in the range.
It's a safe dose.
We multiply by 4 here, that changes it to a day instead of per dose.
Oh,
Does that make sense?
The 4 there is essentially unitless, basically, because it's 4
Yeah.
times, but essentially you could get rid of the times and just say that 4 is unitless. But yeah,
Right, because he's really doing the 40 milligrams, 1, 2, 3, 4 times. Milligram, you're adding them,
It
right?
just
Milligram
scales.
plus milligram plus milligram.
it just scales the milligrams. It's basically unitless.
Yes,
so 4
exactly.
times.
but how would you figure out, I guess, would you divide this by 4 to figure out the single dose? Or
Well, we know the single dose is 40.
The dose is 4.
If you wanted to figure out milligrams per kilogram,
yeah, isn't that, yeah. I don't know if you wanted to do that, because sometimes they'll give them to you and they'll, I remember in nursing school, we had to do all those dosage calculations, but as time went on, you know, that they provide all that for you. If you don't use it, you forget how to do it.
because there's several ways to do this.
So it's 40 milligram pills pretty much 4 times a day. So
Yeah.
he's taking 4 of them in one day.
What we've shown here is what they're saying is if he's having a 40 milligram dose 4 times a day, how many milligrams is this child taking in per his body weight per day?
Oh,
And so by taking this dosage, this is how much he's taking in per his body weight per day.
yeah, okay.
It's not total, it's in terms of his body weight.
Yeah, that's how much he's taking, how much he's taking in per day per his body weight. Again, this wasn't like Professor Gauss said, this isn't a conversion, we're using the same logic to make sure our units end up in the right place.
Yeah, so, if you just wanted to say, ignoring the weight of the child, so just like covering this up, then your units would be 40 milligrams per day. And then you could say, well, you can compare that, if your child weighed, 8
Yeah.
kilograms or something, you could change that factor every time.
You could, but couldn't you
Really
find
be
out
40
like the
milligrams
weight of
per
a
day.
child, like in pounds, cause isn't it 2.2 kilograms to 1 pound?
It's 2.2 pounds to 1 kilogram.
Okay, I had that.
Yeah, 2.2
But if
pounds
you
to 1
wanted to
kilogram.
figure out the actual, like, convert the weight to
You wanna make
kilograms.
this so that it's milligrams per pound per day?
Yeah, if
How
you
much?
needed to do that.
Let's do that conversion. What factor would you add on to the end of this? How can we make this so that it is milligrams per pound per day?
Would be,
Milligrams.
isn't one milligram is 1,000?
So is a milligram smaller or bigger than a gram?
It's bigger than a gram.
A milligram is smaller than a gram.
Milligram,
Yeah,
yeah,
grams bigger.
milligram smaller than a gram.
So when we
1
are
gram is
going
about
from
1
milligrams into grams, we're going to a bigger unit, right?
Yes,
So we should be going to a smaller number, right?
right,
There are 1,000 milligrams in a gram.
yes.
Mhm.
1,000 milligrams per gram.
1,000 milligrams in 1 gram. Notice
Yes,
bigger unit, smaller number.
yeah.
Yes.
She actually said if you cover up the weight, it would be 40 milligrams per day, but it wouldn't actually be 40
It'll be
milligrams per
160
day.
per day.
Because
160
it
milligrams
would
per day.
be 40 milligrams per dosage,
Yes,
4 times per day.
yes, yes. You covered up this, it would be the milligrams per day total, yeah. How many grams to a pound conversion?
So 2.2 pounds is 1 kilogram.
Oh, it's 1 kilogram.
Yeah, 2.2 pounds is 1 kilogram.
Yes, you could change that.
There's 1,000 milligrams in a gram. There are 1,000 grams in a kilogram.
Right.
Yeah, there's 1,000 grams in a kilogram. And then 1 kilogram is 2.2 pounds.
So what do I do here? So if I 50, you see the bottom off, you can see.
You wanna write grams to kilograms
It
above?
won't work, it's too small.
I mean, above it, you wanna put the grams to the kilograms.
So, what
1,000
now?
grams.
1,000 grams?
Yeah, a kilogram.
Okay, that's okay. I'm gonna have to move I'm gonna put it over here, so y'all can't see the bottom of my screen and I can't write any lower. So if we had 50 milligrams
Per kilogram.
per kilogram per day, how would you convert it to, what did you say, pounds?
Milligrams per pound per day.
Milligrams per pound per day, how would you do that?
So you
You have to convert the weight into pounds.
put the,
I think we only need one of our conversion factors. Yeah.
one,
Because you need to go from kilograms to pounds, right?
Kilograms per pound, right?
Everything else is the same, milligrams and days.
so it'd be
Give units.
yeah.
One, how many?
One over two.
One what?
One what?
One kilogram.
Kilogram.
2.2 pounds.
And then you're done, because your units are
Then you're just gonna-
milligram in the numerator, no, sorry, not for one. Kilogram in the numerator, kilogram in the denominator. So they have milligrams in the numerator, you have days in the bottom and pounds in the bottom.
So 50 divided by 2.2.
So approximately 22.73 pounds of milligrams per pound per day.
22.72.
That's a small child.
That's the dosage per
Well,
minute.
that's the dosage per
That's not
pound.
the child, that's the dosage per pound per day. That's the safe level. Or that's what this drug is, it's 22.73 milligrams per pound per
Do
day.
you want to convert the child's weight to pounds? The child's weight is 3.2 kilograms.
So 3.2 kilograms, how do we do it?
So you have a 3.2 over 1, and then 1 over 2.2.
One what, give the unit though.
1 kilogram.
But if I put kilograms up here, what
Oh,
happens?
wait, no, you can't do that.
Yep.
So it'd have to be the 2.2 on the.
Yeah, I always start on the bottom, I say I need kilograms, let me put the kilograms
Yeah,
for
the
this one.
kilogram on the bottom.
Yeah.
It's 1 kilogram at the
And
bottom,
then
right?
the 2.2 pounds on top, so then that would cancel out the kilograms.
So what is the pounds of the child?
So 3.2 times.
A pound is smaller than a kilogram, so should the number get bigger or smaller? Bigger. Yep, we're going from bigger unit to smaller units, so our number should get bigger.
What do you get?
So
7 point what? Oh, 4, something like that?
yes, ma'am.
7.04 pounds?
7.04, yes.
That's
a
a
small
child.
child.
Oh,
It's a
my
baby.
Yeah, that's like an infant, yeah.
It's a newborn.
Yeah, it's like a newborn, yeah.
It's a preemie, preemie baby.
Any questions for us?
Just thinking of it.
And if you have not done so already, everybody on WebEx, put your name and your V number and your teacher. I think most of you have.
That baby.
Thank you all for coming.
Thank you all.
Oh,
Yeah, thanks.
thank you.